Okay, this video is 2B, and it's the second topic in Chapter 2. The purpose of this video is to look at rate of change, slope, and graphing lines, basically, and two different ways of doing that. So again, a major objective is understanding how to find slope, understanding its relationship of one unit compared to another unit, and then how to put, I guess not so much graphing lines, but linear equations, and understand the difference between standard form and slope-intercept form, which we know is y equals mx plus b. So let's go ahead and take a look at um, slope. Okay, so what's rate of change? Okay, so slope is basically comparing one change versus another change. So we're talking about like the slope of the roof, how far it goes up versus how far it goes over. Or, dollars per hour would be an example of rate of change. Anytime we have a unit where you're comparing one unit to another unit. So here's different ways that we see it. There's the equation in Levis, this thing where you find the difference of y's over the difference of x's. Same thing here. That's another symbol. The triangle means difference of. We hear it as rise over 1. Basically, we're looking for the vertical displacement over the horizontal displacement. So rate of change or slope is the comparison of two things. And that's why we have an angle that shows that relationship. Okay, and what we're really talking about here in this chapter is the relationship of that slope. We're very familiar with this with y equals mx plus b, where m is that slope. Okay, so that's very familiar to us. So again, how do we find the slope between 2 points? If you had an ordered pair, you simply take the y values, -8 and 3, and you find the difference between them. Again, it doesn't matter which one comes first, as long as you're consistent. So in this case, 0.2 comes first. So it's 3 minus -8. Notice the double negative. And then 10 minus 15. So we have 11 over -5. So that would be the slope. So that's the vertical displacement. We go up 11 for every 5 we go to the left. Okay, so we have a negative slope overall. So again, the different types of slopes that we should be familiar with is positive slope as it goes to the upper right, negative slope as it goes to the lower right. Zero slope, notice, is a horizontal line, and undefined slope is up and down, because notice you have vertical displacement, but you're dividing by 0. So let's just kind of see this as numbers. So here we have, for zero slope, what's our vertical displacement? How far do we go up and down? Nothing. And divided by some sort of x value. So let's, the x value is whatever number you want it to be. But notice 0 divided by any number is 0. Whereas over here, what's our vertical displacement? Well, whatever the displacement of y is. Let me put the triangle here. And what's a horizontal displacement? Notice the line's not going left or right, so we say 0. Well, we can't divide anything by 0. That's impossible. We call that undefined, so we just simply say undefined. So that's how you're going to see that. Okay, so here's an example of rate of change in application problems, and this is really what we want to be able to get after. Some examples, the distance you drive in 1 hour, miles per hour would be a great example. How much your salary increases per year. So salary increase. So it'd be like dollars per year increase. Okay. So like I said, all different types of examples, we'll see that as well. So let's take a look at the word problem down below here. Okay. The U.S. Number of U.S. cell phone subscribers increased from 16 million to 44 million over this time period. Find the average rate of change. Okay, so a lot of times you want to think, okay, so what makes sense, label-wise? I always like to start with label, and here we're looking at this right here, subscribers over time. Okay, the number per year. Okay, so a lot of time makes sense to go on the bottom because we can't really change time. So we're looking for relationship versus time. So notice we start with the label, which makes sense. We're not going to put years on top, say, how many years per one subscriber. That doesn't make sense. So start with your labels and then figure out what numbers go there. So the number of subscribers goes on top. So we subtract them, find the difference, the growth, divided by the change in years. We're talking from 93 to 96. It's a 3-year difference. And simply we divide that, and there we go. Okay. And then it says find the number of subscribers in 1997. So this is y equals mx plus b. So here's y equals, here's your slope, plus b, or starting point. Well, we know we started at 44 million in 1996. So in here we're talking about, you could pick either 96 or 93. Some people say, well, shouldn't we put this one down first? You just need to pick a point to start from. So your number of years, you're talking relationship to your starting point. So since we're talking 97, that's only 1 year removed from 96. We put 1 year. So think about it. You started 44 million in 96. You add this relationship for 1 year, and you get 53.3 million. Okay, so that's a great way of looking at that. All right, so here's two ways to look at parallel and perpendicular lines. Okay, so notice they're both in y equals mx plus b form. But what we're looking for is, how do we understand if lines are parallel or perpendicular? If the slopes are the same, we have the same rate of change. Notice they're like railroad tracks, they won't intersect. The thing that's the same is the slope. Okay. Perpendicular is one has to be positive, one has to be negative, and the slopes have to be reciprocals of one another. So if this is a slope of 2 over 1, then this needs to be a slope of 1 over 2. So notice it's flipped and negated. So we call this a negative reciprocal. Okay, negative reciprocal. So that's the difference between that. Notice the b values do not matter. Now here obviously you have to have different b values, because if they were the same b value, then it'd be the same line. So here you definitely need different b's. Let's make a note here. So you have to have different b's. But here the b, doesn't even matter. Okay, because we're really just looking at the slope. So you got to take mind of that. All right, so let's just talk about y equals mx plus b, slope-intercept form. Now, the whole purpose of this form is to isolate the output. So notice this goes back to our function. Here we have an input relationship. So you plug in an x value, input, you calculate it, and out comes y. So function notation looks like this. What is the function if x is whatever? So you plug in a value of x. So if x is 2, you plug 2 into the equation, and you figure out what the y would be. So here's a great example of input-output. Now the reason why we use y equals mx plus b is it's a great a way to put the equation so we can graph it easily. We have a starting point and we have a slope, which makes it easy. Okay, so notice here our starting point is 4, and then we have a slope of up 2 and then over 3. No big deal. So here we have our slope and our starting points, and like I said, it makes it nice and simple. So this should be pretty common for a lot of us. Now the other thing I want to talk about is standard form. Now again, standard form is not really designed for graphing purposes. It's designed for a way to organize information, so if we're comparing it to other equations, it's easy. Like if we have to solve systems and use substitution or elimination, everything's organized. And standard form is this. You put all the variables on one side, and then you put the number by itself on the other side. And a lot of times we put the letters in alphabetical order. So if we're comparing it to another equation where you had a different equation, you stack your x's, you stack your y's, and you put your numbers over here. So that way we can compare x's and y's and numbers. So that's what we're looking for there. So that's the kind of purpose of standard form. But from standard form, we have to know how to do two things. One, convert it to y equals mx plus b, and that's simply solve for y. So you'd move this over here, and then you'd divide everything by b when you did that. Okay, so that's how you could do that. But another way to do it is to find the intercept form. And we're saying, okay, the nice thing is we can find where it crosses the y-intercept and where it crosses the x-intercept. If we cross the x-intercept, then the y value is 0 right here. So you plug 0 in for y, and then solve for x, and notice we get the point -2, 0. If we input -2, we get 0, so that makes sense there. Down here, we do the exact opposite. If we input 0 anywhere on this line, this vertical line, the y-axis is x equals 0. So maybe let's label that so we can kind of see that. This line is, oops, that's a horrible x equals 0. And this line here is y equals 0. And that's, where we can see that. And let's just highlight those so we can kind of see exactly. So we're talking about y equals 0 and x equals 0. So let's highlight those. So here we're talking about if you plug 0 into the equation, Notice that goes to 0, and we only have to solve for one variable, and y equals 4. So when x is 0, y equals 4. So once you have 2 points, use a ruler, connect the lines, and you got a line as well. So notice we didn't have to find a slope. We just found 2 points on the line, and then just connected a dot. So that's a nice, easy way to do that as well. So again, you want to know the difference between slope-intercepts for graphing and then standard forms for comparing, but we should know how to use that information and graph it. Okay, special cases, vertical and horizontal lines, x equals, we just kind of saw that before. Anywhere on this line, the value of x is 3. So if I pick out a point right here, that point is 3 comma 3. And notice I use parentheses around it. Down here, if I use that point, it's negative 4. I'm sorry, 3 comma negative 4. So it should be, let me erase that there. Pencil got away from me there. There we go. So let's fill that back in. So if I have this point right here, that point is 3 comma negative 4. So notice we have a x value of 3 both times. Anywhere on that line is going to be 3. Whereas likewise over here, anywhere on this line, the y value is negative 2. So what's the equation of the line? Y equals negative 2. So if I was to say graph this in negative 4, we would say like, 0x plus y is equal to negative 2, And notice we have no x values. So this kind of is in standard form. Variables on one side, numbers by themselves on the other side. So that's a good way to see that. Okay, so that kind of concludes this video. I want you to try graphing these 3 problems. If you don't have graph paper, that's fine. Just sketch a x and y axis and just kind of sketching the line. You got to get used to doing that. And then down here, determine if these 2 lines are parallel and perpendicular. So you need to compare the slopes. So let's go ahead and start with that.